Hello class, this is a video tutorial on the application of direct linear proportions to conversion graphs. In this video we're going to be doing three things. We're first going to interpret graphs and then determine whether they are in direct proportion. We are going to then write an equation, between the two variables, and then we're going to use that equation in part B to predict future values that are not shown in the graph. So let's get straight into it. And here's our first example. Here I have a conversion chart between kilograms to pounds. We have kilograms along the x-axis and pounds along the y-axis. Let me just zoom out just a little bit here. There we are. And we're going to be determining whether or not kilograms and pounds are in direct linear proportion. Here we go. So the first part we're going to be doing is first, by creating a table, we can use the values in the graphs to, in combination with, so part A, we're going to use the table with the idea of P over Q equals K. But in order to get here, we first need a table of values. Let's get straight into it. Let's use the value, let's put K for kilograms along the x-axis and P for pounds along the y-axis. And the values I'll be using will be 5, 10, 15, and 20. 5, 10, 15, and 20. Easy enough. Obviously, depending on the graph that we're given, the values we use may change. But for this particular example, I'm going to be using 5, 10, 15, and 20. Okay. So now, in order to fill in this blank spot, all we do is we go to the kilograms, go to 5, and then we move up to the point where it hits that orange line. And as you can see, it is not directly in line with the blue squares. It's actually, if you take a look, it's about halfway between that. So first we determine how much this goes up by. There is 1, 2, 3, 4, 5. And if you just do some quick calculations, you can see that each box is worth 2. So 2, 4, 6, 8, 10. So since that point there is 12, this is about halfway. This will give us 11 pounds. Let's do the same thing for 10. 10 is here. Let's go all the way up. This time it is directly in line. And since it is going up by 2 along here, so 20, 22, the value here is going to be 22. And already we can establish some sort of pattern happening here. Let's continue. 15. I'm going to follow that line along there. That line along there. So that point there doesn't hit the line once again. Whoops, where are we? There. Don't want to lose it. If we go across this time, that is 30, 32, 34. So it's in between 32 and 34. So it must be 33. And finally, we're going to do the last one for 20. I'm pretty sure you can sort of see a pattern happening here. But let's just be sure to make sure that we don't miscalculate. So 20 all the way up to that line there. Moving all the way along. Second one, 40, 42, and 44, just as we predicted. So we've now interpreted our graph, and we're now going to no longer use this. We're going to use these values here. It makes it much easier than having to go back to the graph all the time. Now that we have a table, we're going to do what we did in the previous example and use this idea of P over Q equals K, but for the values that we have here. So in this one, it's actually going to be, it's always going to be the second. Let me draw another column here. It's going to be the second value, P, over K. Let's take a look here now. So it's going to be 11 over 5. And if we grab our calculator and see what that is equal to, we have 11 over 5 is equal to 2.2. So that's the value we're going to be using, 2.2. Let's check now. For the rest, 22 over 10. Same thing on the calculator, 22 over 10, also 2.2. Oops, 2.2. And I'm pretty sure if we follow this along, it will be the case that we'd find that all of them will be 2.2. Let's just double check here. 33 over 15, 2.2. Oops. And 44 over 20, also 2.2. So since we've found, using our definition, okay, since, we'll write since P over K equals 2.2, we've found that the lowercase k, the constant, is equal to 2.2. Therefore, P and K are in direct proportion. Let's answer question B now. Question B is to write an equation of two quantities in direct proportion. So we have here the direct proportion. So we know that P over K is equal to 2.2, but we're going to make this into P equals 2.2 K. And this is the linear equation we're going to be using, not this one. So this is the linear relationship between P and K. And finally, let's go question C. In question C, you can note that kilograms only go up to 20, 21, 22, 23, about 23 is where it ends. And for the pounds, it stops at 50. So we can now use our equation P equals 2.2K to predict values that are not shown here in our graph. So let's do it for any two values that we want. Let's say how many pounds LBS is 1 ton. In case you don't know, 1 ton is going to be 1,000 kilograms. So in this example, what we're going to be doing is we let K equal 1,000. And we substitute this value in our equation here. So we get P equals 2.2 times 1,000, which will give us 2.2 times 1,000, 2,200 pounds. 2,200 pounds. So we can write the statement now that 1,000 kilograms is equal to 2,200 pounds. However, in American units, or sorry, imperial units, we can also, they also use the value of a ton. So we can say is how many kilograms is 1 ton. However, they use the same value, same word, ton and ton, but it's going to be this time 1,000 pounds. So in this example, we're going to let P equal 1,000. And we substitute that value into our equation here. So we get now 1,000 equals 2.2 K, and we want to solve for K in this one. What we do is we're going to divide by 2.2 on both sides. I'm going to continue my working out here. So we're now going to have K is equal to, we're going to find out, 1,000 divided by 2.2 divided by 2.2 gives us about 454 points. I'm going to round it off to 2 decimal places. 5 kilograms. So now we can officially say from this graph that 1,000 pounds is equal to 454.55 kilograms. I hope this has given you an insight in the application of direct linear proportions to conversion graphs. Best of luck.